All right, hello everybody. I'm going to go over with you a very brief overview of how to solve absolute value equations, which covers section 2.8, objective 1. Here we go. First thing we need to do is to define an absolute value, just to make sure we're all on the same page. The absolute value of a number is its distance from 0 on the number line. So here's a visual example for you. Notice the number line, which goes off into infinity in both directions. To the right, it's moving toward positive infinity. Toward the left, this other arrow points going off to negative infinity. And here there's a darker tick mark which represents 0, or the origin. And any number's distance away from that point is going to constitute its absolute value. So for this example, we use the number line to plot -2 and 2, and we will measure the distance, the number of units away from 0, in order to capture the absolute value of -2 and the absolute value of 2. Here we go. So I plotted -2 in red and 2 in green. We count 2 units away from the origin in both instances, so both -2 and 2 have the same absolute value of 2. Okay? Great, moving on. So if we want to solve equations of the form something inside of absolute value bars equaling something else, then we need to come up with a procedure for that, right? We need to understand that there are actually 2 different cases that we need to entertain. Either the capital X in this case could equal positive A or negative A, according to this very generic general case. Okay, so let's go ahead and use that in order to solve this equation here. It's relatively simple. We just have the absolute value of y equal to 5. So right away, you want to break your absolute value equation into 2 cases, and that's going to be either equaling 5 or -5. Now, since there was nothing inside of the absolute value in order to evaluate to get straight to the variable, we can go straight to the final answers, which is a solution set of two values, both -5 and 5. Okay, moving on. Now let's solve an equation that's a little more complicated. So here we have the absolute value of 4x plus 2 is equal to 6. So straight away, split that into your 2 cases. Either the 4x plus 2 is equal to 6 or it's equal to -6, okay? Now in both, we could solve these 2 cases simultaneously. We could do them one at a time. What I'm going to show you in this PowerPoint, in this lecture video, is showing the solution of them both at the same time. So in both cases, in order to solve for x, we are going to start with subtracting 2 from both sides. So that's what that'll look like. And we will get 4x equals 4 for the left-hand side case, and the right-hand side case, we will get 4x is equal to -8. Now in both cases, to move forward with finding the solution, we will divide both sides by 4, simplify everything down, and it looks like x will either equal 1 or x will equal -2. And that's it. That's all there is to it. All right, moving on. Let's solve this next equation. And again, because the absolute value and the expression inside the absolute value is equal to a positive number, that's really why we get to split it into the 2 cases. Now we'll see an example coming up, hint, hint, hint. Heads up, there's going to be an absolute value equation that's set equal to a negative number. In that case, we do something special. You'll see that when we get there, okay? But since the absolute value expression on the left-hand side is equal to a positive number, split it into the 2 cases. Either x over 3 plus 4 is equal to +1, or x over 3 plus 4 is equal to -1. Subtract 4 from both sides in both cases in order to move forward with the solution. And then you'll need to multiply both sides by 3 in order to solve for x for both cases. So let's do that to both sides of both equations and simplify everything down, and you will find that in this case either x equals -9 or x equals -15. Cool. Moving on, here's another more complicated example, and there's a preliminary step that you will need to take in order to solve this absolute value equation, and it is to isolate the absolute value term all on its own, one side of the equation. That's when you are allowed to split into the two cases, but only if it's appropriate. So let's go ahead and start by just subtracting 9 from both sides, and we will get that the absolute value of 5x equals 10. Now it's time to split this equation into the two cases. Now 5x can either equal positive 10 or negative 10. Divide both sides by 5 in order to find those values of 2 and negative 2, which would become your solution set for x in this case. Okay, moving on. Here's a tricky but kind of weird one, but it's something that we should address just to make sure we know how to deal with it. The absolute value of x is equal to 0. Well, then what would x be? X just equals 0. 0 is one of those special numbers that does not have a sign. It's the gatekeeper between realms, is the way I like to think of it. It's the fence by which you hold in all the positive numbers and the negative numbers. So it's neither positive nor negative / both positive and negative at the same time. People have different schools of thought on this. Personally, I think it's neither. That's my thinking. It's the gatekeeper. Okay, so yeah, 0 is 0 units away from itself. It's another way to think of it as far as like linking back to the original definition of an absolute value. Makes sense. Okay, next example, we have a few steps to perform before we're ready to split this equation into the two cases, because only the y variable is inside of the absolute value bars. So let's go ahead and start by subtracting 20 from both sides. We will get 3 times the absolute value of y equals negative 9. Divide both sides by 3, because you want to isolate that absolute value component. And then at that point you can split the equation into the two cases, so long as your absolute value is equal to a positive number. Now notice what we have here. The absolute value of y is equal to negative 3. That's an impossibility. Absolute values cannot be negative because absolute values are distances, and distances are always positive, right? They're measurements, right? They can't hold a negative value. The context doesn't make sense for us, so we limit the value of an absolute value evaluation to be strictly positive. Okay, so here you would say you have no solution, or you could use the symbol for the empty set, the little 0 with the slashy through it. Okay, moving on. Here's a really fun one, but notice something straight away. We have absolute value. There's lots of stuff, interesting stuff going on inside. Oh, disregard my smartwatch there. There's lots of stuff going inside of that absolute value. We want to bust it open by entertaining the two cases, but can we do that? Well, no, because look, the absolute value is set equal to a negative number. It's like a trick question. So we simply say that there's no solution or use the empty set symbol. Okay, cool. Now what if your absolute value equation has absolute value quantities on both sides? How do you move forward in trying to solve those equations? Well, you'll just entertain the two cases. You'll pick one of the absolute value expressions, and you're going to entertain the case where they're both as originally stated, and then you're going to pick one to be negated. And by one, you're going to pick one side of the absolute value equation when you have this form, and you're going to negate it, and that's going to be your other case. Okay, here we go. So here's one such example. We have absolute value expressions on both sides of the equation. I'm going to choose to have the 3x plus 5 be negated, and you have to negate the entire expression. So make sure you put it in parentheses and then distribute through that negative sign. And then, of course, the generic quintessential case over here onto the left is just going to be drop the absolute value bar. So that's one case, and then there's another case in which you negate one side of the equation. Now, we're going to distribute through the negative sign here. I'm just going to keep this the same. All right, maybe this side over here didn't need to be rewritten down. Next, we can move forward in 4 different ways for each case. So let's see what I chose to do. It looks like I chose to subtract 3x from both sides on the left-hand side case and add 3x to both sides on the right-hand side case. And here's the result of those. Now we will, in both cases, add 5 to both sides, and we will get either x equals 10 or x equals 0. I know it says 7x equals 0, but divide both sides by 7 on this right-hand side case, and you will eventually explicitly have that x equals 0. Cool. And that's the solution set there. All right, let's try this again with another example. I'm choosing to have the right-hand side be negated for the second case, just like I did for the previous one. If you wanted to do it the other way, that's perfectly fine. It doesn't really matter because equations are symmetric. So if you switch the sides of an equation, it's still the same equation. It's still equivalent to the way it was presented previously. So distribute through that negative sign. We're going to add x to both sides on the left-hand side, subtract x from both sides on the right-hand side, simplify all that down. Notice that something interesting happens on the right-hand side over here. We have reached a contradiction. All of our variables canceled themselves out, and we came across an impossibility here, right? 2 equal to negative 4? I don't think so. Put a slash through that and say that there's no solution over here on this case. But now let's continue to solve the equation on the left-hand side. We'll subtract 2 from both sides. We will divide both sides by 2, and then we will say that there is one solution, and it's that x equals 1 from this first case over here. Okay, so sometimes you might encounter impossibilities, contradictions, cases that don't go anywhere, and that's okay. These things happen in absolute value equation solving from time to time. And that'll do it for this endeavor. Please let me know if you have any questions about these items or others when we get back to class. Thank you so much for your attention, and I will see you soon.